Good morning all. Last day we have studied about embedded C++. Embedded C++ is a programming language which is used for embedded system design. And by using embedded C++, we can get a compact, efficient machine code which will be burnable to our embedded system. And this embedded C++ and embedded C programming language are mainly used for low configuration embedded system. But recent years, due to the development of semiconductor technology, the cost of embedded system comes down. So the memory size and the performance of the processor is no longer a criteria for embedded programming. So nowadays developers are more often using embedded Java over embedded C and embedded C++. You can see that there is a lot of embedded Java devices are working today. For example, we all have a mobile phone, and the mobile phone operating system is completely developed using Java programming language. Likewise, there are many applications for embedded Java. These are the agendas of this session. Initially, I'll give an introduction to Java. Here I will discuss various characteristics and features of Java programming language. Then we will understand what is the difference between C and C++ with the Java programming language. Later we will see what is the problem with the desktop version of Java. Desktop version of Java is nothing but the standard version of Java. Then we will see what is Java embedded. It is the Java version which is specialized for embedded system. Java is a general purpose programming language, and it is developed by James Gosling when he is working in Sun Microsystems. And Java is released in 1995. After initial release in 1995, there is lot of versions of Java has been released, and the latest version of Java is Java 14, which is released in 2020. The syntax of Java is similar to C and C++. So a programmer familiar with C and C++ can easily program in Java. Now we will see what are the characteristics of Java, or why Java is so popular recently. The first characteristic of Java is it is an object-oriented language. An object-oriented language has a class method architecture. So from a class, the signature of the class, we can create as much as object we wanted. So there is a lot of possibility of code reuse in object-oriented language. This makes the application development very faster. So many people prefer object-oriented language than the function-oriented languages. And other characteristic of Java is it is less prone to errors than C. because in C language there will be pointers. The pointers will often generate errors. So since there is no pointers in Java, there is very less chance of error in Java. And the memory management of Java is automatic, and it can be achieved using a garbage collector which is built within the Java runtime environment. But in the case of C or C++, we have to manually allocate the memory using malloc function. Then later we have to deallocate the memory. And if we forgot to deallocate memory, then there will be some memory leak. If many times or the memory leak happen, then there won't be no memory, there won't be any free memory will be available, so the application will crash. Java is a portable language. It means that the application developed with one CPU architecture can be run in another CPU architecture. For example, suppose our application is being developed on a Windows x86 PC. Then the same application can be run in Linux AMD 64 architecture without any modification. And the same application also can be run in Android. You all know that all the Android phones are having ARM architecture. So it is very portable. So we can say that it has a write once run everywhere functionality. And the next feature of Java is it has a security oriented architecture, and it has many libraries which support security and encryptions. And Java is a multi-threaded programming language. Since it is a multi-threaded programming language, it can make use of multiple core of the CPU. In comparison to other programming languages, Java has a large collection of OS independent libraries. This include libraries for database access and libraries for graphical user interface. And the database access libraries can be used by the programmers for developing server applications. And the GUI libraries will be needed by the developers for developing some office applications or games, etc. We all know that Java is slower than both C and C++. So sometimes it may need to improve the speed of a program segment. Such times we can write that segment with the help of C or C++, and we can call that method directly from our Java code, so that the overall performance of our system will improve. And it is possible to debug our Java program from a desktop, or we can debug remotely. It is possible because Java is a portable architecture independent language, so that the embedded system application we can directly run from our PC, and we can emulate the embedded system from our PC and debug it easily. and after debugging and validation we can copy the code to the embedded system to run it. Now let us look into Java execution steps. The program written in Java first fed into a Java compiler, and it will give Java bytecode as output, and this Java bytecode will be fed into a Java runtime environment, and inside Java runtime environment there will be Java virtual machine. It will run this Java bytecode and we will get the output. And this Java runtime environment consisted of Java virtual machine, a class loader, bytecode verifier, and Java class libraries. Now let us look into the problems of Java Standard Edition. It is nothing but the desktop version of Java. The first problem associated with the Java Standard Edition is it is too big, because in order to run a Java bytecode, a machine need Java virtual machine along with the supporting libraries. And in the case of Java Standard Edition, the minimum size of Java virtual machine and libraries is around 16 MB. But an embedded system, this much RAM and memory may not be available. And the other problem associated with the Java Standard Edition is that it is too slow, and Java is almost five times slower than normal C code. Another problem with the Java Standard Edition is that there is no notion of address in Java Standard Edition. It means that it is impossible to access the I/O devices of embedded system through hardware address. And in Java Standard Edition, they are providing security, portability, and dynamic behavior, but it is not needed in much of the embedded systems. In C and C++, we can allocate the required amount of memory using malloc, and once the processing is complete, we can free the memory using free command. But in the case of Java, the memory management is automatic. It means that we do not need to deallocate the memory, and this automatic memory management is made possible by Java garbage collection. This Java garbage collector collects the unused memory when it is went out of scope of our program. But this Java garbage collector is dangerous, because when this Java garbage collector runs, all the processing will stop, and it induce a stop the world effect. But in the case of embedded system, this stop the world effect will be dangerous, because an embedded system will be a real-time system and it has some real-time constraint. So during the stop the world effect, the embedded system is like a halt state. This is not good for a real-time embedded system. And in the case for Java, the memory allocation is not fast enough like C, and it is not predictable. The application space of Java embedded is so large. It can be used in ATM,
printers, scanners, smartphone, and in telecommunication and in industrial control application, smart card and smart appliances, then in connected card and sensors and in various actuators and smart energy meter and smart health appliances, etc. The application space of Java is so large, so developers created many editions for Java. The main edition of Java is Java SE. It means Java Standard Edition, and it is used for desktop environment. Then it come Java Embedded Edition, and there are two flavors for Java Embedded Edition: Java ME Embedded and Java SE Embedded. Java ME Embedded is used for low performance embedded system, and Java SE Embedded is used in high performance embedded system. Then there will be a Java card and Java TV editions. The Java card edition is used for designing the smart card applications, and it has some extra security components will be added in this edition. And Java TV edition can be used for designing the applications which can be run on TV. And for database management, we can use Java DB edition. Last slide I have said about various Java editions, and these Java editions are suitable for different environment. For example, a smart card like application, it is best to go for Java card edition, and for other low purpose embedded application we can opt Java ME embedded, and for high performance application we can use Java SE embedded. Now we can see what is Java ME embedded. It is also called Java embedded. According to Oracle, Java ME embedded is a complete Java runtime client, and it is optimized for ARM architecture connected to microcontrollers and other resource constrained systems. And this product provides dedicated embedded functionality and is targeted for low power limited memory devices requiring support for a range of network services and I/O interfaces. And the Oracle Java ME embedded is designed to meet the needs of intelligent and connected service on resource constrained devices, such as those found in wireless module, building and industrial controllers, smart meters, tracking system, environmental monitors, healthcare, home automation devices, vending machines, and more. Now we can see the characteristic of Java ME embedded. The Java ME embedded implementation is done with two standards. One is CLDC and the other one is MIP. The CLDC standard stands for Java ME Connected Limited Device Configuration, and the MIP stands for Java ME Embedded Profile. And this Java ME Embedded can be used in target devices with very low memories. And it is said that this Java ME is possible to use in embedded devices with memory little less 128 KB of RAM and 1 MB of ROM. And Java ME embedded also provide various API to access GPIO and I2C and SPI and UART devices. And it also provides various wireless connectivity support such as 3GPP, CDMA, Wi-Fi, etc. Java Embedded provides lots of API to access the peripheral devices of embedded system, and it also supports many tools such as tools to debug, monitor, and log all the resources connected to the embedded systems. And this Java ME embedded emulation environment can be run in Windows and Linux. And this also Java ME embedded also support headless operation. Headless operations means that we can run Java embedded edition in devices without any graphical user interface or any input or output devices. And it also don't require a high performance operating system to run this Java ME embedded environment. It only required a small real-time operating system or a small kernel in order to run this Java embedded environment. And this Java embedded support all the ARM architecture SoCs. Java SE Embedded is the high performance version of Java Embedded. And in order to run this Java SE Embedded, the embedded system should have high performance capabilities. It means that it has higher memory capacity as well as higher processing capacity, and a full OS should be deployed before installing Java SE Embedded. Let us summarize what we have studied. In comparison to Java Standard Edition, Embedded Java is specialized for embedded devices, and it is deployed in billions of devices around the world. And the Embedded Java is designed to be very portable, flexible, and secure, and it offers wide set of functionalities. And the embedded Java can be deployed in tightly hardware constrained systems because the memory footprint of embedded Java is very small. Thank you.